Hello teachers, welcome back to section 7-4. This is part 2 of the video. In part 1 we wrapped it up with looking at a few examples of true false, and this is another one. So let's just say we're in Clean City and the fine for various polluting activities is a certain percentage of one's monthly income. It says the fine for smoking in public places is 40%. For driving a polluting car is 50%, and for littering is 30%. It's a little bit harsh, don't you think? Mr. Smuts committed all 3 polluting crimes in one day and paid a fine of 120% of his monthly income. What do you think about that? Is that true or false? More like, is that possible or impossible? If you'll recall from the last video, we had a problem that talked about a population and it added to more than 100%, and we said we can't do that. You can't have a population that adds to me more than 100%. It was 105%. But you know what? In this case, 120% of a salary is possible. You can have more than your salary. Now, you wonder how he paid it. He's going to have to pay it with, more than 1 month's salary to get it done. But you can have more than 100% of certain things, and 100% of a salary is totally possible. So yes, this is a true statement. Now let's talk about compounding interest. Suppose you borrow $6,000 from a bank at simple interest at a rate of 5% to be paid off 2 years from now. So there's a lot of key information here. So this amount right here is your principal. So the $6,000 that they give you is your principal. And in a simple interest calculation, this would be either the amount that you owe or amount that you borrow, okay, or the amount that you invest. Sometimes it could be simple interest investment. The 5% represents the interest rate, okay, and there always needs to be a period of time. So the period of the loan is the amount of time you owe the money, which in this case is 2 years. Okay, so simple interest has a formula, and the formula is I, which represents interest, equals P, which represents principal, rate represents the interest rate, and it is a percent that you have to change to a decimal, and T represents time in years. Okay, so again, your R is going to be some percentage rate that you change to a decimal. Okay, or you could leave it as a percent and type it in your calculator. So if it was 20%, you'd have to type in 20%, but it's smarter just to change it to a decimal, which would be a 2/10. Now here you see a formula for the total amount. So remember the formula we had earlier, which is I is equal to PRT, is just interest. Okay, well what if you want to know the total amount of the loan? Well, notice that would be your principal, which is the amount that you owe, plus the interest that you need to pay. And then they substitute in for your I value, your PRT. If you'll notice, you could factor out a greatest common factor of P, and that P comes out front, and that's going to leave you with 1 plus RT. So this formula right here, A is equal to principal times 1 plus RT, would be the total amount of the loan. So let's do an example. So Vera opened a savings account that pays simple interest at the rate of 5 1/4% per year. If she deposits $2,000 and makes no other deposits, find the interest and the final amount for 90 days. Okay, so we want to know the interest and the final amount. So first let's calculate interest. So I is equal to P times R times T. And let's figure out what everything is. So I is what we're looking for in the beginning, the interest, my bad. What is the principal? That's $2,000, right? And the rate is 5 1/4%. If you like, we could change that to a decimal. So R would be, let's write it down, 5 1/4%. We know that 1/4 is 0.25%. And if we change that to a decimal, remember 2 places to the left, that would be 0.0525%. Right? So 2 places to the left. Now percent, I'm sorry, we lost the percent. 0.0525, which is really 525 10,000ths. All right, so that's my R. And what's my time? Well, it's 90 days, but if you'll remember time, when we talked about it just a few minutes ago, let me go back to that page for you real quick. Time is down here at the very bottom of the page, is in years. Okay, so this particular example, it was 2 years. Our problem, let's go back and look at it, it says 90 days. That's not in years. So what do we do about that? Well, we have to turn it into a year. So 90 days is 90 divided by 365 days in a year. So we're looking at this in terms of a ratio. So 90 days out of a total of 365 days. And if we multiply this all together, feel free to use your calculator here. And I'm going to show you their typed up version. We have 2,000 times 5.25% times 90 over 365. Again, what they did not do for us here, and I wanted to make that real clear for you, is they did not change that to 0.0525, right? We handled the 5 and the quarter, and we converted it to a decimal. Now, calculators can handle you typing it in directly like this. That's possible too, but I want you to really see what's going on with that calculation. And it still don't have the answer, do we? So they multiplied it. Hey, look, they changed it for us. There's the 0.0525 times 90 over 365, and that gives us $25.89. Now remember, that's your interest only. That's your I value. Okay, well notice it says find the interest and the final amount after 90 days. So you would have to pay the principal plus the interest to get the total amount. So that's going to be your $2,000 plus the $25.89 interest. So you get $2,025.89 due after 90 days. And there's that total that we were just talking about. Okay, let's check out example number 21. Veer, open. Oh, we finished it. Oh, they're just writing it in sentence form. It's like, what? We did it all. There it is. The interest is approximately $25.89, and the final amount is approximately $2,025.89. Now let's do another problem. Find the annual interest rate. Okay, so this time we're looking for a rate. If a principal of $10,000 increased to $10,900 at the end of 1 year. Okay, so the principal of $10,000 increased to $10,900. So doesn't that mean that we earned $900? If you take $10,900 minus $10,000, that's going to equal to $900 in interest. So that's how much we earn. Now we want to know the rate. So we're going to use I is equal to PRT. Now my interest is $900. My P, what is my P? Is it 10,000 or is it 10,900? Well, it's the initial amount. So that's going to be 10,000 times my R. That's what I'm looking for. My T is 1 year. Remember, your time always has to be in years. So how do I calculate this? Well, what I need to do is 900 divided by 10,000 times 1, which is 10,000. And that's going to be my rate. Now remember, this is going to give me a decimal. So 900 divided by 10,000 gives me 0.09, which we know that is 9 hundredths. But now if I change that to a percent, I move the decimal 2 places to the right, and I get 9% is my annual interest rate. Okay? Now, let's see their calculation. So R percent of 10,000 equals 900. They did it a little bit differently, but they still got the 9%. We really didn't do it differently. We just focused on the formula, and they wrote that a little bit differently. Okay, well, what if you have to calculate percent decrease or percent increase? Well, to calculate percent decrease or increase, you must consider the original value of the item and then the new value of the item. And I say value of the item, we might be talking about population. So how much was the population originally versus how much it is later. You might be talking about a dollar amount. So there's different values you could be talking about. But it's the difference in the amounts. It's always positive. So when you subtract in the numerator, always do biggest minus smallest. But key here, divide by the original amount. Now, why times 100? Because that's going to change it to a percent for you. Because when you just take the difference and then divide by the original amount, that's just giving you the ratio, okay? Times 100 will change that value to a percent for you. And you have to add the percent sign. Okay, so let's do a problem. Okay, during a sale, a dress price decreased from $99 to $72. What was the percent decrease? So we want to use our formula here. How much did the value change? So the bigger one is 99. So we start with 99. 99, we start with a pen that works. Try it again, sorry y'all. 99 minus 72. And then we divide by the original amount. And so that's what you have to be the most careful of. The original amount was the $99. And it's not the bigger one. For a percent decrease, it will be the bigger one. But for a percent increase, it won't be the bigger. It'll be the smaller one. So don't pay attention by which one's larger. Focus on the original amount. And then, of course, you can subtract 99 minus 72 is going to give us, what, 28? Divided by 99. I type that in my calculator. We know that 28 divided by 99 is equal to 0.28282828. So it's just repeats, but that's the decimal. If I'm going to change that to a percent, I need to multiply that times 100 or move the decimal over 2 places, but that would be 28.28. That's the repetin down there. It keeps repeating percent. Okay, now I have a few homework examples for you. I just want to make sure you're comfortable with these. It says John paid $400 for a new mountain bicycle to sell in his shop. He wants to price it so that he can offer a 20% discount, but still make 10% of the price he paid for it. At what price should the bike be marked? Now, I'm positive you can handle this on your own, but I just wanted you to see the example. Okay, so first of all, we're going to deal with this 10% situation. We want to mark up the bicycle so that there's a 10% markup on it. And then after that, we'll mark it up another 20% so he can cut the price 20% if he needs to and still make 10%. Does that make sense? Okay, so I'm going to take our $400 and I want to mark it up. So I'm going to multiply that times 10%, which is 0.10 or 10 hundredths, or 1/10 if you like. Okay, now $400 times 10%, that's going to be $40. Okay, well that's going to bring the price up to $440. Okay, well now we want to mark that up an additional 20% so that later on, when John has a sale, he can mark it off 20%, but he still makes 10% profit. He still gets at least $40 profit on the bicycle that he sells for $440. So now we're going to move on to calculate the 20% of not the 400, but of 440. So I take my 440 and I multiply that by 20%. Okay, or 2/10 or 20 hundredths. And we know that's going to be $80, right? No, that's not right. It's 440 times 20%, not 400 times 20%. That reminds me of, one of those true-false questions we did at the end of the last video. So 440 times 20% gives me $88. So I've got $88 on that I add to what? To the 440, And that means that John needs to charge $528 for the bicycle originally. And when he does that, if he decides to have a 20% off sale, he's still going to make $40 on the bicycle. Now here's an example of another homework problem. It's not necessarily number 2. This is just my example, number 2. They want us to complete parts A through D. These are super just basic percent problems. These did not show up in the work we did. We actually did more application type problems, but I just wanted you to see this happen. So question A, we're calculating 72 is 40% of what number? Okay. Now remember, we've got 2 ways or more. Really, there's more. You could do part over total equals percent over 100. You could do is over of equals percent over 100, or you could use an equation. And I'm going to show you all 3 for A, and then we're going to fly through the others, okay? So 72 is 40% of what number? Okay. Now, to me, the second listed way is a much easier way to handle this. Really, these are the same 2 formula, but the words in the second one. So I'm not going to address it like the first one. So 72 is, that's your is number. So 72 is, now 40%, that's clearly your percent number. 100 is just part of the formula. So 72 is 40% of what number? That's the value we don't know. And this is a proportion. So we do 72 times 100 is equal to 40 times x. We know 72 times 100 is 7,200 equals 40x. Then I'm going to divide 7,200 by 40, and that's going to give me my x value. And 7,200 divided by 40 gives me a result of 180. Now the thing about 180, you got to make sure it's not your percent answer. If it was percent, you'd have to add the percent sign, but that's not it. Now, the other way we could do it is with an equation. So 72 is means equals 40%. So change that to a decimal when you use this in equation form, because the 100 is not there for you. That's the same as 40% of means multiply. What number means x? And once again, we would take 72 and divide it by 0.40, which is not the same as what we did earlier, but it's the same value as what we did earlier, right? So you still get 180. That makes sense? Now, let's knock out the other 3. And I think this, to me, is really the easier way, especially if you don't want to solve algebra problems, although essentially it comes out to about the same no matter which way you do it. All right, let's see what we can do with question B. Okay, so what is, so I'm missing my is number, 9%, so 9 is my percent number. I'm going to put it over 100. That's 9% right there. Of number is 130. So we cross multiply, so 100x is equal to 9 times 130. And then that'd be 9 times 130 divided by 100. And when I plug that in my calculator, stand by just a second, 11.7. And again, make sure you're not looking for percent. You're not. That's your is value. Now, if you did that in equation form, so what is, so we don't know, is 9%. So you could type in 9% in your calculator or change it to a decimal times 130. And that's going to give you 11.7, just the same. All right, let's check out example C. 47 is, so 47 is my is number. Is what percent? Hey, I'm missing my percent number this time, so I just put an X in the percent spot, still over 100. Of, there's my of value, 23.5. Again, you cross multiply, you'll get that. Or you can set it up as 47 is, because is means equals, what percent of, we don't know the percent, of means multiply, 23.5. And then we would do 47 divided by 23.5. Now, remember, you're looking for a percent. So 47 divided by 23.5 gives me the decimal 2. But you've got to change that to a percent, so that's going to be 200%. Now, if you solved it here, you would get 200 immediately for x, because that's already dealing with the percent sign. So be careful which method we use. Do you add the percent sign? Do you not add the percent sign? Okay? And then for question D, so again, 14 is, so 14 is your is number. 20%, so 20 goes in the percent sign. We put it over 100. That handles the percent sign. Of what number? That goes in the denominator. And then you cross multiply. So 14 times 100 is equal to 20x. The next step would divide both sides by 20 to get that x by itself. And your answer will be right there. In equation form, it says 14 is your equals 20%. I need to change that to a decimal or type in my calculator 20% sign of what number. And so now I have 14 divided by 0.20 equals x. And I'll actually do that in my calculator. And I get 70. And also look at it to make sure it makes sense. It's not that your part is always going to be smaller than your total, but often it is. And when it is, then your percent is less than 100. Whenever your percent's over 100, your part is bigger than your total, right? Sometimes percents over 100 don't make any sense, but sometimes they do. Like for the guy that had to pay fines, he had over 120% of his salary that was due. Now I've got one more problem for you here. So it says a person collected $6,300 on a loan of $5,400 they made 9 years ago. If the person charged simple interest, what was the rate of interest? And we've actually done a problem similar to this in this lecture. But let's just make sure we're comfortable with everything. So we had a dollar amount of $6,300 and another dollar amount of $5,400. Okay, so the loan is actually the $5,400. So that's your principal. What's the 9 years? That's your T, right? Now, if the person was charged simple interest, that means we get to use the formula I is equal to P times R times T. Now, do we know the interest? Actually, we do, right? Because that person collected $6,300 on a loan that's $5,400. So that means the interest I has got to be $6,300 minus the $5,400, which looks to me about $900. Okay, so we've got $900 is equal to principal. Remember, we already established that was $5,400. Your rate is what you're looking for. The time is 9 years. Okay, so what could we do? We could go ahead and multiply those two values together. So 5,400 times 9 gives me 48,600 R, and that's 900 on this side. Now, what do we do next? So we have 900 equals 48,600, and now I'm going to divide 900 by 48,600, and that's going to be my interest rate R. And I get a result of 0.018518. Now notice directions here says type an integer or decimal rounded to the nearest hundredth as needed. Now remember, this formula, your answer doesn't automatically put this in percent form. This is just a decimal rate. So if I was going to write this in terms of a percent, I would need to move my decimal 2 places to the right and then round. Don't round first. So that would be 1.85%. So right here. 1.85%. Hopefully that'll help you with the homework and help you get your work done. If you have any questions or concerns, please let me know. Have a great day.